Hello, my name is Braden Goddard, and I'm an assistant professor here in the Department of Mechanical and Nuclear Engineering at Virginia Commonwealth University. So my specialty is a lot with nuclear engineering. So in the spectrum of mechanical and nuclear, I'm pretty far in the nuclear, almost like a physicist. And so I like radiation. I do a lot with radiation detection and things like that. And where we're standing right now is our radiation measurement and detection laboratory. So we will bring our undergraduate juniors, but even graduate students in here and teach them how to measure radiation. We measure beta particles, alpha particles, gamma rays, neutrons, the full suite of common radiation that you would see. We have all kinds of instruments. Here's your grandfather's detector, where you plug your wires in and you turn your knob, sonny. We also have more modern things, like this micro detective. We just got this, I'm super excited. This is the detector that emergency responders use. So if someone discovers that there is a nuclear weapon in New York City, the people who deploy will be using one of these, along with other equipment. So we train our students on the exact equipment that they're used for, the most important jobs in the world. So this is really neat. Don't drop it. It's about $100,000. But every single detector we own is, I think the cheapest is about $200–300, and then they just go up into the thousands. Apparently, detecting radiation is very expensive. We have some other cool things in this lab. Over here, we got donated to us a mock-up of a nuclear fuel assembly. So there's no radioactive material in it, because it's a mock-up. But it gives us a visualization. So, students study things on paper on the computer, diagrams, but this is the actual size of what it is. We can see the fuel pellets here, the uranium, how big they are. You can even see how the little metal's twisted to help fluid twist and flow up to prevent boiling from occurring. So you can see all these neat little features. I actually like this chart a lot here. We try to get a visualization of radiation dose. Everyone's scared of radiation, but this chart, it's actually XKCD made it, their webcomic, but it shows you a good visualization. Here, this is how much radiation dose you get from eating a banana. And this is how much you get from living within 50 miles of a nuclear plant. So if you're willing to eat a banana for the radiation dose, then you should be willing to live near a nuclear plant. So very visualization here, very hands-on. You have to learn the theory, but I prefer the experimental. It's more fun. One thing I'll say, so I'm trying to get everyone to be a nuclear engineer because that's what I am. One thing I'll say about nuclear engineering is it's surprisingly multidisciplinary. So, you say, oh, I'm an electrical engineer, I learn, electronics. I'm a materials engineer, I understand materials. If you study nuclear engineering, you study everything. Because we have to understand the materials that go in the reactor. We have to understand the chemistry of the water that goes through it. You have to understand all the electronics. It turns out we use a lot of electronics, the thermal hydraulics, the fluid flow, the reactor physics, the radiation interactions, the particle physics. So nuclear engineers, actually, when you get out, you can really do any engineering, to be honest. We teach you a little bit of everything. And then we teach you nuclear, so no one else can do your job. So I really like nuclear engineering. You learn a lot of cool things, and you have really good job security.
What kind of things happen in this lab?
So some of the experiments we do in this lab, so we'll bring undergrads in, they come in here, we have them take radioactive sources, they'll put it underneath detectors, connect the wires. We are big into having the students, when they're done with this course, be able to do everything themselves without help. And that's important because guess what? In the real world, you might be the expert. Actually, right after I graduated, I went to work in a foreign country, and they needed a radiation expert to help them with security aspects. So I looked around the country, the different organizations. We tried to help them find the expert, And the scary conclusion was I was the expert. With like 1 year of experience, and I was the most knowledgeable on this very niche topic in the whole country. So yeah, you may be the expert, and you might not be able to go to other people for help, so you have to be independent. So we put radioactive sources and different things, pull measurements, and you see the radiation data. You can identify what type of radiation is it. Is it something like medical isotopes? Is it natural background radiation? Is it industrial sources? We even have some special nuclear material. This is things you use to make weapons with. We can ID that, and so really help you understand it. We do radiation safety aspects, so we'll put shielding. So we have boxes of lead that's been taped up, and so you can measure it and say, okay, this much lead reduces your radiation dose. We do distance and shielding, where we do measurements, and you say, okay, place the detector, the person further and further away, and you can see, wow, if I can just take an extra step away, that really helps me with my radiation dose. So don't cluster all around the radioactive material if you're not using it.